In this lecture, we're going to examine a concept known as vapor pressure. Recall that inside a liquid phase, the molecules or atoms are held together by bonds known as intermolecular bonds. And these intermolecular bonds are a result of the electrical forces between the protons and the electrons on adjacent atom or molecules inside the liquid phase. So let's suppose we have the following closed container, and inside this closed container we have a liquid. Let's suppose water. Now in the space above the liquid we have a vacuum, so an absence of atoms and molecules. So if we take a microscope and we zoom in onto the microscopic level, we'll see that the liquid molecules, the water molecules, are moving about with a great variety of velocities. Some are low and some are high. Now we define the root mean square velocity of each molecule by the following formula. The square root of 3 times k times t divided by m, where m is the mass of the water molecule, k is the Boltzmann constant, and T is the temperature given in kelvins. Now notice, as we increase the temperature, we increase the velocity, and therefore we increase the kinetic energy of each molecule. Now if we examine the water molecules that are close to one another, notice that they are held by these intermolecular bonds, which are a result of the electrical forces between the subatomic particles, the electrons and the protons. Now let's suppose we take the same exact container that has a vacuum above this liquid and we examine the molecules found on the surface. So the molecules on the surface of our liquid, of the water, that have a high enough velocity will escape the intermolecular bonds, the electrical forces, and will move into the empty space above. So some of these molecules found on the surface will not have enough kinetic energy to escape the electrical bonds, the intermolecular bonds, and will remain in the liquid state. But some of these liquid molecules that have a high enough velocity and therefore a high enough kinetic energy will escape into the empty space above. And this process is known as evaporation. So, once again, molecules on the surface that have high enough velocity will escape the electrical forces and move into the space above, becoming gas molecules. And this process is known as evaporation. Now, these evaporated gas molecules will fly about the empty space, and some of them will hit this liquid, will hit the surface of the liquid, and some of these molecules that hit the liquid surface will remain in the liquid, and this process is known as condensation. So condensation is the opposite of evaporation. Condensation is going from the gas state back into the liquid state. Now, when the rate of evaporation is equal to the rate of condensation, well then our two systems, the liquid and the gas system, are at equilibrium. So equilibrium will be reached when the rate of evaporation is equal to the rate of condensation. And at this point, we can measure the vapor pressure. The vapor pressure is the pressure in the space above the liquid as a result of the gas molecules hitting the walls of the container. So this is known as vapor pressure. Now we can also talk about a concept known as boiling, which is different from evaporation. So as you increase the temperature of our container, so let's suppose we take the following container and we open the container at the top so that these molecules are are now in contact with the molecules found in the atmosphere. So as you increase the temperature of our liquid, more of these molecules gain the kinetic energy required to escape the liquid and enter the gas phase. So as you increase the temperature of the liquid, more molecules have enough kinetic energy to escape into the gas state. So we increase the temperature, we increase the velocity, and we increase the kinetic energy of our liquid molecules. So this increases the vapor pressure because we have more molecules escaping, we have more molecules in the gas state. And so more molecules are hitting the walls of the container, and so we have a higher vapor pressure. When the vapor pressure equals the external pressure, in this case it's the atmospheric pressure, when the vapor pressure is equal to the atmospheric pressure, boiling takes place. And at this point, the molecules inside our liquid, not only on the surface of the liquid, but inside of our liquid, when these molecules have a high enough kinetic energy, they will readily escape into this region here. And that is known as boiling. And bubbles of gas will form inside our liquid, and these bubbles will rise into the space above.